The LCM and HCF are two different important factors of mathematics while solving many of the problems, and we have discussed about LCM and HCF in the lower classes. So let's come as a recap to discuss about what is LCM and HCF in mathematics. So LCM, which stands for least common multiple, and HCF, which stands for highest common factor, are the two important aspects we are going to discuss today with examples. So here, if I take two numbers, let me start with LCM and HCF, the least common multiple and the highest common factor. So if I take two values, 12 and 18 are the two numbers I take, and I want to find the LCM of 12 and 18, and I want to find HCF of 12 and 18. So let's see how we are going to find for each of the answers and then differentiate between understanding the LCM and the HCF. So coming to this, let me start with 12, and using the prime factorization method, I should be able to find all the possible products in primes for 12. So as we know that 12, when taken in with prime factorization method, 2 times of 6, 2 times of 3 can be written as 2 square into 3 power 1, because 4 3s are 12 and there are two primes which are 2 and then 3, which can be written as 2 square times of 3. Therefore 12 can be written as 2 square times of 3 power 1, because these are the possible factors in prime, the prime factors for 12. Similarly, I find the prime factors for the other number in this example being 18. So when I want to find the product of primes for 18, again I try to find by prime factorization method the different possible factors, 2 9s, 3 3s and 3 1s, so that 18 can be written as 2 power 1 times 3 square, as can be seen from here. 2 into 3 into 3 can be written as 2 power 1 times 3 square. Now with these two, my LCM, if I wanted to find the LCM of 12 and 18, then I use the method where it says that LCM of 12 and 18 is nothing but the product of the greatest powers with common prime factors. Now LCM of two numbers is defined as the product of the greatest powers with common prime factors. This is how we understand LCM connected with prime factors. So let's see how we can simplify the LCM of 12 and 18 using this exclusive method of identifying the product, identifying the greatest powers with common prime factors and then multiplying them. So in this case of 12 and 18, I identify that the greatest power here is 2 power 2 and the greatest power here is 3 power 2. Therefore, for each of them, the product of the greatest powers with common prime factors. So here I find the common prime factors 2 squared and 3 squared. Therefore, the greatest powers here are this and this, which I'm going to multiply as 2 squared times 3 squared as the product using the statement out here. So in this case, I get this to be 2 squared, which is 4, and 3 squared, which is 9. 4 times 9 is 36. Therefore, LCM of 12 and 18 is said to be 36. So LCM of 12 and 18 is 36 by using this concept. The least common multiple of 12 and 18 is equal to 36. So coming to the next, if I wanted to find the HCF of 12 and 18, the highest common factor of 12 and 18, then also I have a formula similar to this LCM of two numbers. So when I wanted to find the HCF of 12 and 18, then this is identified as the product of the least powers, here being the greatest powers. I have here product of the least powers with common factors, with common prime factors. So when I identify the least powers here, clearly I identify that the least power here in case of 12 is 3 power 1 and the least power here is 2 power 1. Therefore, when I want to find the HCF of 12 and 18, I take the product of the least power 3 power 1 times the least power in case of 18 2 power 1, so that I get this times this, and this gives me the answer to be 3 times of 2, which is 6. Therefore, the highest common factor of 12 and 18 is 6, and the least common multiple of 12 and 18 is 36, is how I identify the difference between understanding of LCM and HCF. So similarly, there's a small note I would like to make here, that HCF is also called is sometimes referred as GCD, the greatest common divisor. The highest common factor is also referred sometimes as greatest common divisor, abbreviated as GCD. Next, one of the most important relation between LCM and GDC in understanding through the connection between LCM and GDC is that they are very much related through a mathematical equation, where if I wanted to find LCM and GDC of two numbers, say A and B, my numbers are A and B, then LCM into HCF is the product of the numbers. If I wanted to find LCM or HCF, I can also use this formula if provided I know one of them, either LCM or HCF, but they are two connected with LCM times HCF is equal to A times B. The LCM into HCF is product of the numbers, is how we understand the concept in this relation, and this is very important because this connects HCF and LCM in with a mathematical equation. So this can be verified using the previous example above here, where A and B are 12 and 18 respectively, and LCM is already found to be 36 and HCF is already found to be 6. So let's see if this verifies very much for any numbers, any two numbers A and B. Therefore, as I already found the LCM of two numbers 12 and 18 to be 36, then 36 times of the HCF, which is 6, must be equal to the product of the numbers, which is 12 times of 18. And as I clearly see that 36 multiplied with 6 is 216, and 12 8s are 56, 12 ones 12, 12 8s 96, 12 ones 216, which is clearly true. Therefore, this theorem, this formula holds true for any two numbers taken into consideration, and therefore this supports the statement.